This is a follow-up of a lab in which you studied the conductance or conductivity of salts in water. The question is, what makes the solutions of 3 salts, when they're in water, conduct almost as well as metals do, metallic wires? Here are the facts. Dry sodium chloride, calcium chloride, and aluminum chloride will not conduct electricity at all. You can take our word for it. But sodium chloride, calcium chloride, and aluminum chloride do conduct electricity when dissolved in distilled water. We need to explain how it is that the salts are insulators when dry, but become conductive when they are in water solution. And not only that, we need to explain this, the fact that as you increase the number of chlorides attached to the metallic ion, sodium, calcium, and aluminum, the conductivity increases. What do you think caused the increase in conductivity as we went from sodium through calcium to aluminum chloride? You may turn off the video so you can have a discussion on this. So we want to make a hypothesis that will explain how it is that these salts conducted electricity in water and how it is that the conductivity increased with a certain number of drops of the same concentration solution increased as the number of chlorides increased. Suppose our hypothesis is that the salts are breaking up into charged particles. First, would that explain how they can convey an electric current in water? Now, how would that explain this? Think about it for a moment. How many particles will these break up into? With aluminum chloride, perhaps the salt with more atoms in them breaks up into more charged particles, and those charged particles can carry the electric current better. Sodium chloride would break up into 2 particles. Aluminum chloride would break up into 1, 2, 3, 4 particles. Now, how is it that the salt is breaking up in water? Let's extend our hypothesis. We start off with a regular solid, like sodium chloride, sodium and chloride, held together by plus to minus attraction. This is NaCl. The water molecules then seem to be able to separate the charged particles from each other, so that we have sodium ions surrounded by water molecules and chloride ions surrounded by water molecules. Ions are charged atom and molecule-sized particles. Many ionic solids are soluble in water, and then they will conduct electricity. Some, however, like lead iodide, which you studied when you studied the law of conservation of mass, some are not soluble in water. That must, if our hypothesis is correct, mean that their ions are too tightly held together for the energy of the water to be enough to break them up. And so we look at lead iodide from our experiment with the conservation of mass as a kind of a prototypical non-soluble salt, something that the water has not enough energy to break into ions dissolved in water.